Hello, this is Felix Biesman, and I will be talking about some work that my master student Victor has been doing, and we'll be using a Turing test or imitation game for transparency. So most researchers in machine learning would agree that explanations can help for better for understanding machine learning predictions better. The common assumptions of explainable artificial intelligence, or XAI, is that these explanations should foster trust between humans and machine learning models. And some researchers, if you ask them, they would not make such bold claims. They would rather say something like, these explanations can help us to do some model debugging and to find mislabeled data points, for instance. So some recent experimental evidence challenges these assumptions that machine learning, that XAI methods help to foster trust. For instance, this study here showed that sometimes showing explanations or showing increased levels of transparency actually led to information overload and made people slower at tasks, and it wasn't really helpful. So that was basically not, well, it didn't lead to trust. And in similar cases here, we found in our work that, well, sometimes people just blindly followed machine learning predictions if they've seen an explanation that looked intuitive enough. So both of these cases show that sometimes explanations can have detrimental effects, the opposite effects of what we wanted them to have. For instance, they can lead to, well, in some cases, even algorithm aversion. So Dietforst's study here is, it's a great study, but it's not directly related to explanations. They showed that people trust humans more than machines, even when they know that the machines are better in terms of their prediction performance compared to humans. And similar effects we can see with explanations. Sometimes when people see too much information, or there are many other reasons could lead to the fact that explanations actually do not foster trust. And the other extreme, too much trust, is also something that we've observed in our experiments, that people follow blindly intuitive explanations. And by intuitive, I mean explanations that look similar to them, similar to human-generated explanations. So we see that, so it's important that humans have a healthy or well-calibrated level of trust towards AI systems. And we see that sometimes explanations can distort the right level of trust into a machine learning system. That's what recent experimental evidence suggests. So the research question that we addressed is that, well, if humans trust humans more than machines, as in the case of algorithm aversion, and we want well-calibrated human AI trust relationships, we don't want people to ignore useful advice from machines that have seen a lot more data than any judge or doctor could have ever seen. But we also don't want people to blindly follow any advice that could also be wrong, just because an explanation looked intuitive to a user. So if we want to calibrate for the right level of trust, we need to account for the ability of humans to distinguish human from AI-generated explanations. The assumption is, if humans tend to trust human-looking explanations more than machine-generated explanations, but they cannot distinguish these two, then we could end up in a situation where people just blindly follow human-looking explanations. So that's why we wanted to set up this Turing test for transparency, just to assess whether humans can actually distinguish human from machine-generated explanations. And so this is what we set out to do in this experiment. So the first, we had two experiments. So we looked at a simple text classification experiment on the IMDb movie review database. And we looked at, first, we ran an experiment to collect human explanations. And then we showed some, some other reviews that the subjects haven't seen before to conduct the actual imitation game, the Turing test for transparency. This is how a Turing test usually works. So, we have some human interrogator, and then we have some human explanations and some AI explanations. And in each round, we would draw at random either a machine-generated explanation or a human explanation. And then we ask the human subject whether this explanation was human or machine-generated. And if the human interrogators can differentiate human from machine-generated explanations, then the explanations failed the Turing test, the machine-generated explanations. And if humans cannot distinguish the two, then these machine-generated explanations passed the Turing test. So this is an example of the first experiment. So we showed a movie review, and then we asked subjects to mark the words that were most informative or most important for their decision to flag a review as positive or negative. And the results from those experiments were, well, first, it's the reviewers pointed out, and this is, it's important to mention this, that these results are limited by the fact that it's a very simple task, and the explanations were also very simple. We asked humans to just provide the 3 most important words for their decision, but that was a deliberate choice, because for these type of for this data set, we had already a lot of data collected, and we could sample the data points in a way that we were sure about the error rates and how difficult the task would be. So, but future work will of course look at more complex tasks and explanations. The finding here, it's just qualitative, but human explanations do not look very different from machine-generated ones. So here, for instance, we have human words without AI words, extraordinary, impressed, recommend for the positive class. And here we have some AI, some words found by the AI in AI explanations without the human words, and those contain, ironically, human. But generally, the words are not qualitatively different at first glance. Then we ran the second experiment, which was the actual Turing test for transparency. So here we showed, whether or not this was classified as positive or predicted as positive or negative by either a human or a machine. And then we showed the words that were important for that decision. And then subjects needed to just provide a label whether or not this was human or AI generated. And the results of this experiment were, well, on average, we see a 53% accuracy in this Turing test. So humans on average cannot distinguish human from machine-generated explanations. And so to conclude, we know that explanations can foster trust, and this is what we actually want them to do. But experimental evidence suggests that explanations can also lead to blind trust and to algorithm aversion or information overload. So like the opposite of trust, both cases, so too much or not enough trust. Then our idea was that we need to account for the human ability to detect machine-generated explanations, because that will an important factor when you calibrate these explanations to not have people blindly follow wrong predictions, for instance. And our experiments show that in simple but common settings like this word highlightings in texts, human explanations do not pass the Turing test for transparency, or the other way around. Machine-generated explanations pass the Turing test and cannot be differentiated by humans. Thanks a lot.